This video is going to walk us through how to solve quadratic applications problems. So a couple of reminders. A quadratic equation is when we have x squared, and then when it's written in standard form, it's written ax squared plus bx plus c is equal to 0. What's going to be really important about this today is the equaling 0 piece. Okay, we need to make sure that prior to solving, using either factoring or the quadratic formula, that the equation is equal to 0. So example 1, if 16 is subtracted from 7 times the square of an integer, the result is equal to 24 times the integer. What is the value of the integer? So we're going to set this up to look like a quadratic expression in standard form, okay? So if 16 is being subtracted from something, that means we would write that as minus 16. We need to be careful that we don't do 16 minus. If it was being added to, then the order wouldn't necessarily matter. But if 16 is being subtracted from something, that's minus 16. It's being subtracted from 7 times the square of an integer. Well, the integer is my unknown. I don't know what the integer is, and so we are going to use the variable x to talk about the integer, and then we'll solve for x, and that will be the answer. If the integer is being squared, so the square of an integer, that's x squared. Okay, and that's where the quadratic piece is going to come in. So 16 is being subtracted from 7 times the square of an integer. So again, anytime you see the integer in this problem, we're going to use x. Then the result is equal to, okay? So when you see this, that literally means equal to. The result is equal to 24 times the integer. Again, we don't know the integer, so we're going to use x here. So 16 is being subtracted from 7 times the square of the integer, and the result is equal to 24 times the integer. So now we have to solve this for x. Again, this is a quadratic equation, and we've only learned 2 methods for solving. We've learned factoring, and we've learned quadratic formula. Regardless of which method you're going to choose, the very first step is to get this into standard form. So I would need to move the 24x to the left, or move the 7x squared and the 16, but usually we want to keep the value of a positive, so we would leave the 7 on the left. And then when I move the 24x, we need to make sure we put it in the right place. That's b, so that should be my second term. And then c is my last term, equal to 0. Now, we talked about this a lot when we were solving, but when you are factoring, when you're finding solutions, in order to be able to factor, that means that your solutions are going to be rational numbers. If your solutions are going to be irrational, that means you have no other choice but to do the quadratic formula. So to determine whether or not my solutions would be rational or irrational, we can use the discriminant. Now on this problem, it's asking us for the value of an integer. An integer is a rational number. An integer is going to be any number, positive or negative, that is not a decimal. So 7, -4, 13, all of those would be considered integers. So we know, because we are going to get an integer as an answer, that the method of factoring will work, okay? So I'm going to first show you the quadratic formula, and then I'm also going to show you factoring for the same problem, and you can choose which method you prefer, which method you think is easier. It doesn't matter which way you choose to solve it. So starting with the discriminant, b squared minus 4 times a times c, that gives me 1024. Now the nature of these problems, that number might just be a bigger number. Normally we would need to do a factor tree for that number when we get into the actual quadratic formula part of this. But here, we know that this is factorable. So the square root of 1024 should be a perfect square. We should get a whole number from that answer, which we do. Okay, so now moving on with the whole quadratic formula, we get x equals the opposite of b, so positive 24, plus or minus the square root of 1024, which is 32. Again, I would make sure that you check that, because if it's not a perfect square, that means that you messed up somewhere, because we would not get an integer as an answer at the end. And then all divided by 2 times a, so 2 times 7. So I get 24 plus or minus 32. Again, that was the square root of 1024, and then 2 times 7 is 14. Now from this step here, you could simplify if you wanted to, but these are all integers, 24, 32, and 14. So what we can do, and you can use the Desmos calculator to help you, but we can now figure out what is 24 plus 32 and then divided by 14. If you get an integer, that's your answer. So here I get 4, that's my answer. You can check going the other way. So if you do 24 minus 32 divided by 14, you get negative 4 over 7. So negative 4 over 7 is the second solution to this quadratic equation, but because it is only asking me for the value of the integer would just be 4. Okay, so let's say that we wanted to factor instead, and we wanted to use the method of the star. That would eliminate all of this work down here, okay? So we would still need to get the quadratic equation to be equal to 0, but then from there, we can fill in our star. So A goes there, B goes in the bottom, which is a negative 24. Then 7 times negative 16 is negative 112. Again, the nature of these problems, that number on the top might end up being a really big number. But what you can do is use the graphing calculator, type in 112 divided by x, and when you get the table, that will give you all of your factors. Okay, so if you do that, or if you just divide by 2, divide by 3, divide by 4, you'll actually find it pretty quickly. This would be 28 and 4. And in order to get a negative 24, the 28 would need to be negative. So then you simplify both sides. This does not simplify. This side would simplify to be negative 4 over x. So my factored form would be x minus 4, 7x plus 4 equals 0. Then to get the solutions, you take both of your factors and you set them equal to 0. Well, knowing what we know about solving and practicing this already, we already did this a couple weeks ago, when you have a coefficient in front of the x, that is going to yield a fraction for my answer. So for this one right here, I'm going to end up getting negative 4 over 7, which is not an integer. So you can choose to work it out, but you don't need to, because I know that I am just looking for an integer. X minus 4 equals 0. If I move to the 4 to the other side, I get a positive 4. That is an integer, so that would be my solution. And so we can see you get the same answer either way. So again, whichever method you prefer for solving is totally fine, as long as you can get 4 as an answer. What I will say about factoring that you need to be really careful of is students will do the star, and then they will just say that their answer is negative 4. They'll get to the end of that process, they'll figure out which one of those is an integer, and then they will just say that that's their solution. But you still need to solve it by taking the factor and setting it equal to 0. Example 2, if 42 is added to 5 times an integer, the result is equal to twice the square of an integer. So another common mistake that I see sometimes is students not including an equal to sign and trying to set up an expression versus an equation. When you see this result is equal to, that is where your equal to sign is going to go in your setup. So 42 is being added to 5 times an integer. Again, we don't know the integer, so we're going to use x to define the integer. This is not saying 5 times the square of an integer, it's just 5 times an integer. So that would just be 5x. 42 is being added to that, so plus 42. And then the result is equal to twice the square of the integer. So that would be x squared. And twice would be doubling it, times 2. So 2x squared. Okay, so that's my setup. Step number 2, I need to get this into standard form. So I need it to equal 0. You can choose to either move the 2x squared to the left or move the 5x and the 42 to the right. Both are the same amount of work because you're just rewriting all 3 terms regardless. It's a little bit easier to solve these problems either by factoring or quadratic equation if the value of a is positive. So since I already have a positive a value, I'm going to take the 5x and the 42 and move them over to the right-hand side. So we would get 2x squared minus 5x minus 42 is equal to 0. So whatever terms you are moving from one side of an equation to another, the signs need to flip, okay? So now, again, you can choose which method you want to solve. I'm going to start with quadratic formula. I'm going to show you how to get the answer using quadratic formula, and then I'll talk about the method of factoring. So we would do b squared minus 4 times a times c. That gives us 361. Again, I would go ahead at this step and just double check that the square root of that 361 is a perfect square, that when you take the square root, you get a whole number. We do, in this case, we get 19. So now for the quadratic formula, it's opposite b plus minus the square root of 361, all divided by 2 times 2, which is 4. So we get 5 plus or minus 19. The square root of 361 is 19, all divided by 4. So then we're going to have 2 different answers, 5 plus 19 divided by 4 and 5 minus 19 divided by 4. You can use the fraction button in Desmos to help you. This one you should be able to maybe just do off of the top of your head. One of the answers will be a decimal and one of the answers will be an integer. So this one gives me 6. So that's going to be my answer. This one would give me -7/2. So the value of the integer is x. If you're going to use the method of factoring, make sure that you're using the equation when it's equal to 0. So this would be 2x, -5. And then 2 times 42 is -84. Because the top number is negative, I know I'm going to be subtracting 2 numbers. And I can use 12 and 7, and the 12 would be negative. So this does not simplify, which means that's going to give me my answer that is not an integer. Okay, one of the sides should simplify to be an integer, then I know that that's going to end up being my answer. Now, I say that, but be careful because -6 is not the solution. The solution was +6. So If I write this in factored form, it's x minus 6, and then 2x plus 7 is equal to 0. So I would set both of those factors equal to 0 and solve. This one is going to give me a decimal. This one, if I add 6 to the other side, we just get x equals 6. So that would be the solution. Example 3, a rectangle has dimensions of x plus 1 and 5x minus 1 and an area of 144 square inches. Determine the value of x and the length and width of the rectangle. So I'm going to go ahead and define the length to be x plus 1 and the width to be 5x minus 1. Technically, it doesn't matter on this problem because it doesn't specify which one is which. But it does give me the area. So to find area, it is length times width. So to start this problem, I am going to multiply x plus 1 times 5x minus 1. And that is the formula for area, multiplying the length times the width. So that will equal the area, which is 144. So now to solve this, I need the equation to be equal to 0 so that I can either use quadratic formula or factoring. You can't take the factors here and set them equal to 0 because the whole equation is not equal to 0. So that method of solving by factoring, once it's factored, it has to be equal to 0 to solve that way. Okay, so I'm going to start by FOILing. X times 5x is 5x squared. Then x times negative 1 minus x plus 5x. 1 times negative 1 is negative 1. So now my parentheses are gone. I can start to rearrange this to get it equal to 0. You could also go ahead and just combine your like terms on the left. I'm going to do everything at once. So if I move the 144 over to the left-hand side, I can combine it with the negative 1. That would make this equal to 0. And then you also have like terms with the negative 1x and the 5x. So now I end up with 5x squared plus 4x minus 145 is equal to 0. So again, you have choices. You can either use the quadratic formula or you can use factoring. I'm going to stick with quadratic formula on this one. If you factor, the number at the top of your star is going to be a very big number. Totally fine. It should still work out. But I'm only going to use the quadratic formula this time. So I would do b squared minus 4 times a times c. That would give me 2,916. And don't worry that that's such a big number. Double check that it's a perfect square. But if it is a perfect square, then you most likely are doing this right. Now, technically, x could be a decimal if you're finding length and width. Length and width could equal a decimal. But the area is 144. So at the end of our problem, if we have 2 decimals, it's not likely that it's going to multiply to be 144. So this should, as long as the area is a whole number, it should work out that we get an answer that is a whole number. So now I would do the rest of the quadratic formula. X equals opposite b plus minus the square root of our discriminant, all divided by 2 times a. So the square root of 2,916 is 54, and then all divided by 10. So again, we can check now our 2 answers, negative 4 plus 54 divided by 10. That would give me 5, and then negative 4 minus 54 divided by 10. And this one's going to give me a decimal. which again, on a rectangle problem, it's okay to have a decimal value for your length and your width, but it does not make any sense for your length or your width to be a negative number. So in this problem, more than likely, you'll get a positive answer and you'll get a negative answer, and it's not possible to be negative. So the value of x is 5. It would be possible for the x to be negative as long as when you plugged it in, the length and the width ended up being positive. But for both of these expressions, especially since the length is just x plus 1, if I ended up with a negative number, I would get either 0 for a length or a negative length, and that wouldn't make any sense. So at the end, and I'll show you how to get the length and width, but at the end of this problem, we can take these two answers and check to make sure that they actually multiply to be 144 square inches. So to get the length was x plus 1. So if I know that x is 5, 5 plus 1 is 6. So the length is 6 inches. And then for the width, it's 5x minus 1. So 5 times 5 is 25. Minus 1 is 24 inches. And again, just quickly double check. 6 times 24 gives me 144. So then we know that our answer is correct.